Today we're going to prove that the log base a of x times y is really the same thing as log base a of x plus log base a of y. In other words, instead of taking the log of a product, we can simply add the logs of those factors. So in order to prove this, the first thing I do, since I see x's and y's, I'm just going to define what my x and y are. So I'm going to say that x is a number, and that number can be represented as some power of a. And same thing with y. I'm just going to say that y is a number, and it can be represented as some power of a. But since x and y are different, it's got to be a different power of a. So I'm going to call that n. So just rewriting or just converting it to logarithmic form then, if I look at the left side here, a to the m is equal to x. So that's telling me that the exponent that I would place on a to get x is equal to m. And likewise over here, this is telling me the logarithm, in other words, is stating that the exponent that I would place on a to get y is equal to n. So we've just redefined n and m in terms of a logarithm. So now I need to start proving that what I wanted to show. So I need to show something about this expression. So the log base a of x times y can now be rewritten, because we just said that x was a to the m and y was a to the n. So on the right side of this equation, I'm just going to rewrite it. Instead of x and y, we're going to call this a to the m times a to the n. Now on the right side of this equation, what I'm noticing is that if I have the same base and they're being multiplied with different exponents, we can simply use the property of exponents that rewrites that by adding the exponents. So a to the power of m plus n. Now just looking at this side, the definition of a logarithm here, it's asking me what exponent would I put on a to get a to the m plus n power. So obviously that is going to simplify to just m plus n, because that is the exponent I would put right here to get this expression. So on the left side we didn't change that at all, so we're just going to rewrite it again. So we have the log base a of x times y, which is what we're trying to prove. So then all I'm going to do now is I'm just going to resubstitute what I said m and n were from above, m and n. So on the left side we didn't change, we still have the log of a, base a of x times y. Now instead of m, up top we called that the log base a of x. And then instead of n, we called that, right up here, log base a of y. So we have successfully proven that instead of taking the log of this product, we can take the logs of those factors separately and add them together.